Okay, 3.5. 3.5. Differentiating compositions. Differentiating compositions. So, so here's the motivation. Okay, so somebody gives you a function. F of x is, say, x cubed plus x cubed plus, I don't know, x cubed plus 1 to the 100. X cubed plus 1 to the 100. It says, what is f prime x? At this point, how would you do it? At this point, how would you do it? And this question is really, I mean, probably some of you already know how to do this using something else. Don't use that something else. Suppose you have only the knowledge that you've gotten so far. So pretend that you've never had calculus before, or maybe you've never had calculus before. This question is really geared to assist people. So how would you do it if you've never seen calculus before? Never had a calculus course before, but only up until using only the tools that we have up until now. Yeah, Becca.
Use the power rule?
Use the power rule. Well, the power rule tells us that, you know, if you have something to a power, right, and you differentiate it, then if you have x to a power and you differentiate it, then certainly you're going to get nx to the n minus 1. Okay, but that's not what we have here. We have something plus something to a power, right? So we can, power rule allows us to differentiate monomials, right? But this is not a monomial, so no good. Yeah, Nico. Yeah, that could be the way to do it, right? You'd say, well, wait, what do you mean the product rule over and over again? So what are you going to break this into? 100 times. Oh, okay. Yeah. Okay. That would do it. Yeah. That would certainly do it. You could say x cubed plus 1 times x cubed plus 1 times x cubed plus 1. Do it 100 times, right? And then say the derivative of that is the first guy times the derivative of the second guy, right? So you get the first guy times the derivative of the second guy plus, you know, the derivative of the first guy times the second guy. Right? And then you could keep on going. Right? You could keep on going. So the derivative of this thing is going to be this thing. I mean, just sort of, you know, iterate all the way down. Or, you know, equally painful would be to create a giant Pascal's triangle, right? 100-row Pascal triangle, and then put the coefficients on, and then just differentiate all the monomials. Okay, that's basically what you have to do at this point. At this point in the game. Okay. So okay. Right. Fortunately, we have the following. Luke, do you have a question?
No.
Yep. Okay. So fortunately, we have the following, the following theorem, which is called the chain rule. And it says the following. It says if you have one function that's differentiable at a point C, if f is differentiable at C, and g is differentiable at f of C, then g composed with f is differentiable at C with the derivative of the composition equaling what? Those of you who've seen this before, the derivative of the composition is going to be, Isaac?
I was going to say differential was.
I'm sorry, I can't hear you say it louder.
Yeah, I don't know.
Okay. Okay, very good. Sarah?
Yeah. Isn't it the derivative of the outside function? That's a derivative of the inside function. So derivative of g. Yeah. Yeah.
Okay. So this is the in case the composition symbol has confused you, right? We're taking the derivative of this thing evaluated at x6, c. Okay. So this will be, as Sarah says, this will be g prime, the derivative of the second function, the outside guy, evaluated at the inside guy times the derivative of the inside guy evaluated. Okay. So the picture you keep in your head, right, is like this, right? The first function is f. The second function is g, right? Here is c. C gets mapped to f of c. F of c gets mapped to g of f of c. Okay. Right, here's the picture. Right, here's the composition map. G composed with f. Right. And what the theorem is saying is that the derivative of the composition map is the product of the derivatives along the way. So you take f prime at c times g prime at f of c. F prime at c times g prime at f of c is going to be g of f prime at c. Yeah, somebody.
I'm sorry, so you're not plugging into
Not into G.
no, yeah, you're plugging into F first, but F isn't. You're not plugging it into the derivative of F, correct? Or are you?
So the derivative of the composition is going to be the product of these derivatives. So G prime evaluated at f of c, f prime evaluated at c.
Okay.
Okay. So this is the composition map, right? The composition map is going to take c to g of f of c, right? But its derivative is the product of the derivatives along the way. In 1 second, this will become clear. So let me just put up how this is written in other notation. So in other notation, people write this like you could write this like this: the derivative of the composition at x equals c. Okay. Sorry. Okay. The derivative of the composition at x equals c equals dg du at u equals f of c times df dx at x equals c. So this is another way that people write the chain rule. The derivative of the composition equals the derivative of g with respect to its variable at f equals c times the derivative of f at x equals c. I don't know. I personally like this. This seems cleaner. This seems cleaner to me. But this is one way of writing it. More imprecisely, you'll see people write this sort of thing: dg dx g df dx. Yeah, is it?
Why'd you say that's more imprecise? That's less precise than the Is it because it doesn't tell you where it's differentiating it at?
Yeah, that's it. Yeah, it doesn't tell you where it's differentiating at. And also, there's something wrong with this in that it makes it look like it's a cancellation problem, as if these were fractions. But there's actually no fractions involved here, right? It's not like you can cancel these guys. So yeah, students often get, because the notation looks like it's fractions, they get the wrong idea that there's some sort of cancellation. Okay, so going back to the initial question, right? Okay, so we have this function x cubed plus 1 to the 100, right? And we want to differentiate it. Okay, so the thing is to recognize this as a composition of functions, right? So let's think of this as one function fed into another function. Right? What are our two functions? Shannon?
X to 100 and then x to thirds.
Okay, so you've got this. First, you've got say f of x is x cubed plus 1, right? That's one function, and then you've got this other function g of something is that's something to the 100. Right? And you recognize that this is g of f of x. So you get g of f of x, right? And so the derivative is going to be, right? So the derivative is going to be g prime evaluated at f of x times f prime evaluated at x. So take 30 seconds or 20 seconds or however little time you need. Write down what this is going to be. G prime at f of x times f prime of x. Okay, turn to somebody nearby and say, this is what it is.
Oh, because it's so sharp. It's 1 squared root. Plus 1.
Okay. Okay. So just for exercise, what's f prime? Somebody just shout it out, please. 3x squared. What's g prime?
100x to the 99.
100x to the 99. Right? So you're just using the power rule. Okay. So then what's this? G prime of x evaluated at f of x. Ali, how would you? G prime of x. You've got g prime of x, and you evaluate that at you put f of x into there.
7, 900, and then 3x squared.
f of x, not
Oh,
f prime. So x cubed plus 1
to
to the 99, and then times f prime of x. Well, f prime of x is right there. Just the x squared. Okay. So that's how you use the chain rule. You recognize the thing as a composition. You differentiate the outside guy. You differentiate the outside guy, evaluate it at the inside guy, multiplied by the derivative of the inside guy. Pretty simple. So let's do some exercises. Here's one. Sine x plus x squared quantity to the 6. So take 1 minute. Should not take you more than a minute. Take 1 minute and do it. Right. So recognize it as a composition, and then differentiate the outside guy, evaluate the inside guy, comes the derivative of the inside guy. Okay, turn to somebody nearby and talk to them. Reassure yourselves. Okay. Luke, how about you? Luke. So first off, tell me what your functions are.
Okay, so f of x is sine x plus x squared. And then g of x is x plus 6. And so it's 6 times sine x plus x squared in parentheses, the fifth times, and in parentheses, cosine x plus 2x.
Great. Right. So you take the derivative of g. Right. You take the derivative of g, and you evaluate that at f of x. Right. Evaluate that at f of x, and then you multiply by the derivative of that. You notice that I used over here. I used a u. I used a u for the variable. I used a u for the variable of g, right? Because f is going from here to here, and then g is going from here to here. So we used a different variable, and maybe that makes things easier when you say let u be f of x, right? Rather than say let x be f of x, because that seems kind of a bad notation. I don't know if that makes things easier, make things clearer for people, but it should actually. Okay, any questions? Any questions? Let's see. Okay, let's do. Okay, let's do this one. What's the derivative of sine of cosine of sine? So this time you have a composition of 3, but you just use your chain rule iteratively. So figure out how to use the chain rule to get this. Okay, turn to somebody nearby and talk to them, please.
Is that right?
Cosine of yes. And then
Like, I usually did it for this part first, and then gonna do
And then we just said that you do the big
and then flipped it. Original, because that's just.
Okay, okay. I'm gonna call on Colton. So Colton, chain rule is about two functions, right? G composed with F, right? You got two functions. You're composing them. What are you gonna choose as your G, and what are you gonna choose as your F?
I don't know if this is right.
Doesn't matter.
Sine times inside x. But, and then my other one was
Okay, so you're saying I'm going to, you're gonna take this composition as G,
Yeah.
and then this guy as your inside guy.
yeah.
Okay, sure. So you say, okay, let G of x be sine of cosine of x. Let f of x be sine of x. Great. Okay. Right. And this function is of course G composed with f. Right. Okay. So then we need to differentiate these guys. So let's take G prime. What's G prime? Right. So what did you say, Luke? Go ahead.
Cosine negative sine.
Cosine. So remember, right? So G, right? So G is itself a composition. G is itself a composition, right? So G prime is going to be what? What's it going to be? Right? Remember how you do it? You differentiate the outside guy, evaluate the inside guy, times the derivative of the inside guy.
Oh.
Right. Okay. Okay. So what will it be? Raina.
It would be, so it would be cosine of cosine, right? Because it's the, and then times negative sine of x.
There's negative sine x. Okay. Okay. Right, and then what's the derivative of f? Colton, how about you? What's the derivative of sine? Just cosine. Okay. Okay, great. So you've divided the thing into two parts, right? And you've found their derivatives, right? And then, so what's the derivative? Colton, I'll let you finish it up since we've got it, right? So you take this guy,
Yeah, you take that guy, and then you need to times all by f originally.
you have to evaluate it at f, right? You have to evaluate it. So again, let me put u's in here just to make it a little bit cleaner to explain. You have to evaluate it at u is f of x, right? So remember what we want. We want the derivative of the composition is the derivative of the outside guy evaluated at f of x times f prime x.
So So you put the sign x's all where the v's are?
That's right. That's right. So you say g prime of sine of x. Well, that's going to be cosine of sine of x 3 times negative sine of sine of x. Right? So that part is your g prime at f of x. Right? And then you want to multiply times f prime of x. Right? Oh, f prime of x is just the cosine. So that'll do. Okay, let me do it again. The derivative of sine of cosine of sine of x. So another maybe more common way to do it is the following. You say, well, I'm going to let g be this guy. Okay, I'm going to let g be this guy, and I'm going to let f be this guy. I'll let f be the inside guy's composition. Those of you who've done the chain rule before probably did it this way. Right? But it's okay. You can do it the other way. Okay. So you say, okay, well, I'm going to, so g is sine of x. F is cosine of sine of x. G prime is going to be cosine. And then f prime, somebody who's not, anybody who hasn't seen this before would like to give it a try? Luke, your hand is up, even if you don't want to.
Oh wait, f prime, the one right there.
Yeah, this f.
It'd be negative sine x.
Negative sine x
Just
times
oh yeah, times. Sorry.
the derivative of the
Oh,
inside.
cosine.
Very good. Times the derivative of the inside. Okay. Okay. So then we need to evaluate. So g prime. So you get g prime evaluated at f of x. You get cosine sine of x. Right. G prime at f of x. So g prime at f of x times f prime at x. Okay. Well, f prime at x is going to be negative sine of x times cosine x. So either way is fine. I should say that people usually do it this way. You know, they say let G be the absolute outer guy, and then let F be everything that follows, right? But Colton did it this way. He said, well, I'm going to take my G to be the first two guys, and let F be this last guy. Yeah, it's not any more difficult. Not any more difficult. But people usually do this. Any questions? Should we let's do one more. Okay, one more. Here it is. The square root of sine squared 3x plus cosine squared 3x. Okay. I'd like you to differentiate that. sine squared 3x plus cosine squared 3x. Okay, turn to somebody nearby and just talk.
I don't know if I did this part right. Would it
Yeah.
Oh, wait, no, it's two.
Is your other front? Oh, so you have this whole thing. This thing. So you have like.
I don't know if I did that part right. So you're adding this to
And then
because the derivative of cosine
Okay, Annalise, how about you? No, actually, before Annalise does it, what's the answer? Can anyone just tell me the answer just from looking at it? So this is partially a trick question,
oh,
right? Lynn?
the answer would be 6 sine. Is that wrong already?
Yeah. So this is a trick question. The answer is.
Wait, is it rear would change to a square root?
The answer is.
Is it 1?
Is what one?
Well, because sine squared plus cosine squared
Is 1, right? So this would be the square root of 1. So we're asking for the derivative of 1. What's the derivative of 1? 0, right? It's a flat function. Okay, trick question. Okay, but okay, even though it's a trick question, we can still pretend we don't notice it and try to do it using the chain rule. Okay, right? So who would like to do it? Annalise is going to do that.
I rewrote the square root function so that it was sine squared 3x plus cosine squared 3x to the power of half.
Okay, sure. Same thing. Yeah.
And then
Well, it is 0, but let's work it out. So how would you get this? How would you get the derivative of this guy? If you didn't recognize that this was a constant and you were differentiating it, how would you get it using the chain rule? So you could do them independently. Yeah, you could say I'm going to differentiate this guy, the derivative, right? The derivative of this guy plus the derivative of this guy. Oops. Right? You'd say, okay, my outside function is the squaring function, right? And then my inside function is the sine 3x. This is sine 3x, right? So you say, okay, so it's going to be the derivative of the outside guy. That's going to be 2. So let's do this over on the side here, actually. So if I have something like this, sine squared 3x, and I'm differentiating, right? You see that this is a composition of 3 functions, right? There's the squaring guy, there's the sine guy, and then there's the 3x function, right? So how do you do it? You sorry, let me come over here actually, and make sort of a general principle clear. So if I have something like this, f composed with g composed with h. Sorry, I should have done this earlier when we did the triple over here. Okay. If I have something like this and I want to differentiate it, the way to do it is what's going to happen is you say, well, I take the derivative of the outside guy, evaluate it at the inside guy, right? Times the derivative of the inside guy, right? Well, what's the derivative of the inside guy? The derivative of the inside guy is the derivative of its outside guy, evaluated at the inside guy, times the derivative of its inside guy, right? So you get that, right? You get f prime at g of h of x times g prime at h of x times h prime of x. Yeah. Right? You're just using the chain rule iteratively, right? The derivative of this is going to be the outside guy, evaluated at the inside guy. I should slow it down. The derivative of this thing is going to be the derivative of the outside guy, evaluated at the inside guy, times the derivative of the inside guy. Well, what's the derivative of the inside guy? It'll be the derivative of its outside guy, evaluated at its inside guy, times the derivative of its inside guy. Okay, and so you see that you sort of peel it down, right? What did you say?
Inception.
Inception?
Just like, it's a dumb joke.
Okay, I haven't watched movies in some time. Yeah. Okay. Yeah. So okay. So you see how it goes, right? You sort of do the outside guy, evaluate it at the inside guy, times the derivative of the inside guy, right? And so on. So here, right? Here we have sine squared 3x, and we're taking its derivative, right? So the absolute outside guy is the squaring guy, right? The squaring function. So I say, okay, I take the derivative of the squaring function, and I evaluate it at the inside guy. Okay. Times the derivative of the inside guy. Well, what's the derivative of the inside guy? Well, I have to use the chain rule again. So I take the derivative of that guy's outside guy, evaluate it at the inside guy, and then times the derivative of its inside guy. Well, the derivative of that inside guy is 3. So you get cosine 3x times 3. Okay. Similarly, for this, cosine squared 3x, right? If I differentiate that, again, I want to differentiate the outside thing first. So I get 2 times negative sine 3x to the 1 times the derivative of cosine 3x, right? Whoops, what am I doing? Sorry. 2 times cosine 3x to the 1, right? Times the derivative of the times the derivative of cosine, evaluated the inside guy, times, again, the derivative of the inside guy. So what that works out to be is 6 sine 3x cosine 3x minus 6 sine 3x cosine 3x, which is 0. Plus 2, 3, 2, negative 3. So you get 0. Right. Question? Yeah.
Which identities do we need to, yeah?
This identity is just the Pythagorean identity. Sine squared plus cosine squared.
Okay, that's it, because some of them are like kind of obscure.
Yeah, I wouldn't worry about it.
Okay.
I'm not going to ask you about like the added addition formulas. This is not a trigonometry class. Okay. 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 Any questions on this? So the main thing to remember is that if you have a sequence of compositions, right, and you're differentiating them, then it's going to be the derivative of the outside, I value the inside guy, times the derivative, right? You get this iterative, thing. Okay, so one last type of problem. All right, I'm not sure if we'll have time to do it, but let's try. Okay, so here's problem 36. So there's a balloon, and it's a sphere. There's a spherical balloon, and you know that the diameter increases at a rate of 2 inches per second. The diameter of the balloon increases at a rate of 2 inches per second. How fast is the volume increasing when the diameter is 8 feet? When the diameter is 8 feet. Okay, so this is the kind of problem that you can do with calculus, and here's how you do it. You say, okay, my first question is how does volume depend on the diameter? Does anybody know the relation between volume and diameter, or volume and radius for a sphere? Volume of a sphere? If you know that the radius is r, say, what's the volume? Does anyone know this? If you don't, it's okay. It's somebody said, Corinna, I think you said 4/3 pi r cubed? Yeah. Volume is 4/3 pi r cubed. If you don't know that, that's all right. Doesn't matter. So the volume, as a function of diameter, is 4/3 pi diameter over 2 cubed. So it's 8, right? 4/3 pi r cubed. Okay. So, okay, actually, we'll do this next time. I don't want to rush it.